Hi, everyone. Thanks for joining today to our webinar on advanced network lighting controls. I'm going to have everyone muted just for now, just so that we can have a smoother process. But if you have any questions, feel free to raise your hand after, and we'll get to your question, or you can just message in the chat for any questions. We're going to give about a minute or two before majority of the group comes in, and then we'll get started. So we can get started now. So again, thank you for coming to today's session. We have myself and Ed's going to be presenting the topic on advanced
Hello.
network and lighting controls. So Ed, if you can share the slides.
Great. So hello, everyone. I'm Ed Rubenstein. I will be your lighting pilot for the next hour or so. Glad to be here. Hopefully everyone could see my screen. We had the usual Teams shenanigans earlier. Prasant and I were talking. So today we're going to be talking about advanced network lighting controls, one of my favorite topics. Lighting is such an important thing. It's almost like a gateway drug when it comes to energy management, but also a huge part of what I think is that really demonstrates the capabilities of energy management. Prasant.
Yeah, so before we get started, I just want to go briefly about our Energy Managers Playbook. It's basically a podcast presented by Save On Energy, and you can find it on Apple Music and Spotify and any other major platforms. But they tend to have bite-sized podcasts around 15 to 20 minutes with guests talking about major topics in the industry. So feel free to check it out. You can see the QR code right here. The slides will be sent after, and yep, I'll pass it on to Ed.
Thank you. Okay, so we're going to be talking about a bunch of things around advanced lighting controls and network lighting controls. And apologies in advance if it looks like I'm ignoring you. Again, team shenanigans. I have to look at my second monitor here. I can't get things set up the way I normally have them set up. But we're going to go through a little bit about lighting basics. To talk about lighting controls and advanced lighting controls, we need to understand lighting basics first of all. We'll then talk about advanced and network lighting controls, a bit of an introduction, the components and things like that. Which ties into how you design systems, some of the strategies that are very common with lighting control systems, and then ending off with a few case studies. I mean, there are many, many case studies out there. These are a few that were chosen because they all demonstrate different capabilities of implementing lighting control systems. So by the end, hopefully people who are attending today will, if you don't already, have a good understanding of some of the technologies of lighting control systems, the benefits of advanced networked and luminaire controls, up and beyond the energy savings. I realize this is an energy management session here, but also the capability it has to really enhance the environment as well. You'll be able to describe major lighting control systems, and then, hopefully get some ideas on how to develop your own projects and build business case, highlighting the dollars and cents, the kilowatt hours, but also some of the other benefits that advanced network lighting controls bring to buildings and the ability to enter to work on advanced energy management. All right, so a few lighting basics. So what are lighting controls? So lighting controls are essentially things that allow us to control when and how lights are used. So you can see the picture here. It's a toggle switch. That is a lighting control. That's a manual lighting control. It's not advanced lighting controls, not the focus of the session today. But again, it allows us to turn on lights on and off. You have these things. Sometimes you open your fridge, the lights turn on. It's tied to functionality and things like that. Now, these are basic ones. That picture is a basic one, but they range from something simple like that or tied to, turning on your car, opening up your dryer, to more sophisticated networks of devices, sensors, algorithms, right? All these kind of things. And it's the more sophisticated systems that we're going to be focusing on today to really explore the potential of them. Oops, sorry, again. So apologies again, teams acting up. So why do we use lighting controls? Why don't we just have simple toggle switches, right? So the goal of lighting controls, and this is really important, is to deliver the right quantity of light in the appropriate quality at the right place during the right time. Lighting, again, is much more than kilowatt hours and how much light and things like that. As most people know, lighting has a huge impact on the way we interact with the world, the way we interact with the environment. And the capability to control that or to amplify that through lighting controls is huge. So please keep this in mind. Like what we're trying to do is the right quantity of light, of the right quality, the right place at the right time. Manage energy wisely, but also use lighting to its ultimate impact. So let's talk a little bit about lighting quantity. There's a few important factors here. One is illuminance. So you hear the terms foot candle or lux. This is really how much light is falling onto the surface of interest. So a lux is if you have 1 lumen falling on 1 square meter of whatever your surface of interest is. A foot candle is the same idea, but it's 1 lumen per square foot. One is metric, the other is imperial. Now you notice I say the word surface of interest because the amount of light that's required, and you can see there's some standards there from the IES in the picture on the right there, depends on the activity that's happening. So the quantity of light differs depending on the activity. And I said surface of interest because, for example, you can't see, I'm seated at a desk here. My surface of interest is to make sure I have the right quantity of light on my desk. I need light on the floor so I'm not tripping on things as well, but I really need to make sure I have the right quantity of light for the most visually acute area, which is my desk right now. The other thing that, and this ties directly into energy management, is the lighting power density. So you can see this is from the ASHRAE standard 90.1. This is the amount of electrical power that you should be able to deliver the right quantity of light in different settings as well, right? So this will be watts of electrical demand for lighting in square meter or square foot. So from an energy management perspective, the ASHRAE standard 90.1 is the minimum standard that we really would like to aim towards. Now, lighting quality, and again, lighting quality is such an important part of providing lighting. We've all seen poor lighting quality, but the ability to have advanced lighting controls, positively impact lighting quality is tremendous, it's huge. So the first thing I want to talk about is the CCT, or the correlated color temperature. This is the color of the light measured in degrees Kelvin, right? So you can see this great picture here. It goes from the lower 1,000 Kelvin, which is candlelight, to 10,000 Kelvin sky blue, and you could see the lighting color is very, very different. The lower the numbers, it's warmer, it's red. The higher the numbers, right, it's cooler, it's blue, it's white. So obviously the color temperature of your lighting is going to be determined by what's taking place in the area that you're trying to light, right? So this is why, again, lighting quality is so important. So if you're having, trying to create a nice peaceful environment, quiet and things like that, you probably want to tend more towards the warmer colors, the lower numbers, 2,000, 3,000, right? Where if it's more of a sterile environment, maybe it's, a hallway or utilitarian, you're probably going to tend more towards the higher numbers, right? So again, what's happening in that space is a big determinant of the lighting quality that you're trying to aim towards. Also, one thing to keep in mind is that higher temperatures, the bluer, the whiter colored lights appear brighter, which is an important part when you're designing lighting systems to keep in mind. The other thing is color rendering index. So this is, or CRI. This is a scale from 0 to 100. The higher the number, the better the color rendering index there is. The higher the color CRI, the better you're able to distinguish between colors. So you can see the right CRI is greater than 90. The oranges really pop. The yellows are yellow. Whereas you get lower and lower, you go to the left, everything's looking kind of more brown and wash out. If you drop even further, some of the old sodium lights and things like that, you can't even tell different colors apart. We've probably all been in situations where there's been poor color rendering. It's not a pleasant environment to be in. But again, the ability to have a higher CRI is determined by what activity is taking place in the space, right? Again, the higher, the better you're able to distinguish between the different colors. Glare is also really important as well. I mean, we're not talking about LED retrofits here, but this is something that popped up a lot in LEDs, is that glare, anyone who's sat in this space where there's glare, be it sunlight or coming in from electric lights, as we see in this picture here, know that it's definitely a health and safety issue. It's going to hurt your eyes, can give you headaches and things like that. And you can see this diagram we have here. It could be, direct glare where the light's shining directly into this woman's eyes, or indirect glare, right? The ability to control lighting levels, the amount of light coming out of fixtures and things like that, maybe it's down to the luminaire basis, where it can really impact our ability to remove glare or reduce glare where it's necessary, right? And you'll see this could come even down to a single light fixture. Maybe you dim it, maybe you turn it off, and again, impacting light quality in a positive way. Okay, so let's talk a little bit about advanced network lighting controls. And you saw there's the message there. Any questions that pop up along the way, ask them. There's being monitored, and maybe we could answer them at the end as well. So what are advanced network lighting controls? So ALCSs, right, are systems that automate, and that's the key word there, automate lighting, right, based on a number of different things. Amount of daylight, schedules, activities taking places in spaces, occupancy, and this is much more beyond the basic switches and dimmers, right? Most places at home, I've got wall switches, I've got dimmers and things like that. Some homes, my neighbor across the street, they've got advanced lighting control systems where they can do much, much, much more. Now, network lighting controls are really just a subset of advanced lighting controls, right? So advanced lighting controls are, it could be one switch controlling 2 or 3 lights and things like that. Network is where you get maybe a bunch of different lights or a bunch of different areas, and they're all networked together. This could be wireless, this could be wired, but it will give you more of a centralized control system, right? And you can see it can really open up different strategies for controlling the lights as well, right? So we'll get a little bit more into that, right? But, for example, a centralized system might be one desk where you control all the lights in the, hospital campus or university campus, where a distributed one might be on a building by building basis, a floor by floor basis. So we're going to talk a little bit about more about this in the next few slides. Now, what are the benefits of the advanced and network lighting controls? Why are we here, right? So obviously, reduced energy consumption. That's a big part of it. You can see here, again, automatically has been underlined. The idea is, delivering light when it's needed and where it's needed. Very simple. If you don't need the lights on, you can either turn them off, or if code requires they be on, you can perhaps dim them and things like that. And you can see there's some indicative savings here, right? So network lighting controls often, my experience has been 50% energy savings, right? So the payback for these things is usually quite attractive. Now, the beauty about this is sort of the driver. This is going to allow you to, build the business case to do advanced lighting controls, but some of the other qualitative things that advanced lighting controls bring to the picture are going to be really what sometimes in my experience pushes the business case over, gets you the approval, or, I'm a big fan of saying makes the environment that you're working in not just more energy efficient, but a better environment for, living, for, providing care, for working or whatever. So energy savings, a lot of people are here for the energy management perspective. They are amazing, a great payback usually, and we'll look at some business cases, but also those savings can be leveraged to not just reduce kilowatt hours, but make the environment that you're providing lighting to a much, much, much better environment. So you could see, I don't know, I mean, this picture, the words here, the potential to enhance lighting quality and experience by adjusting light levels and colors to meet user needs. I don't know if this is a better experience in this picture, but you could see that it's a fantastic, like especially with LEDs these days, and you can change colors and things like that. So here you could see lights have been dimmed, I bet you there's the ability to turn lights off, maybe they're occupancy sensors and daylight sensors, but also look what they've done with the colors, right? This room is very different than if it's just pure, one color light, right? So again, it's going to be the energy savings, which is going to drive a dollars and cents business case. But, if you need, if you're in a space that has, you do different functions, right? So maybe it's a gym by day, but you do different gymnasium by day, but you do maybe different events by night. The ability to enhance that by implementing advanced lighting controls is going to be a huge benefit beyond the energy savings. Also, if you're doing network lighting controls, you can see this person here is sitting in front of a bunch of computer screens, right? But it really allows you to do remote monitoring, right? So, there's network, there's information being collected at the fixture level, at the network level, maybe distributed level, right? Remote monitoring will allow you to look at maintenance. You could tell if lights are not working perhaps, right? It could give you occupancy data, energy use, and even for security, which we'll go over. But you could see that, if there's information being collected and through a network, it's being sent to some sort of controller, that data then can be mined, can be analyzed to get information on things up and beyond just the lighting itself. And we'll talk a little bit about that in the next few slides as well. Enhanced safety and security. So this is an interesting one. So I mean, I've been doing energy. I've been doing energy management for over 20 years, including some lighting systems, advanced lighting systems, basic lighting systems, and things like that. And we had some really interesting conversations in the early days about safety and security. So I remember very clearly wanting to put in some occupancy sensors in an area, which if the area is empty, the lights would turn off. And the first reaction from security, and this was a while ago, was we can't do that. We need the lights on all the time. But then through discussion with them, we were able to come to a realization that by having, lighting controls and occupancy sensors specifically, it really helped enhance security. And you could see here, the first bullet point, right? So if there's no occupancy in an area, the lights will be off. As soon as someone enters an area, maybe it's an infrequently used area, maybe it's a parking garage or a hallway or something like that, the lights will turn on. It's a good indication for occupants of the area to know that there's somebody there. And also, when I was talking to our security team, they had remote, monitoring through cameras and things like that. If the area was dark and they saw the lights go on, they would realize there's occupancy there, right? So by having a great conversation with them, and I spent, a lot of time talking with them and building that relationship, we were able to realize that, hey, we can actually not just, save energy, but enhance security by implementing advanced lighting control. You can also see simulating building occupancy. So I remember, as a kid, we'd go away and my parents would put a timer on the lights so the lights would turn on at nighttime and then they would turn off, when everyone's supposed to go to bed, making it seem like there's someone in the house, right? Same thing with larger buildings and advanced lighting control systems. You could kind of emulate there being occupancy there. So people from the outside, they don't know if there's someone there. They just see the lights turning on and off, and they could say, hey, I'm going to stay away from that building because it looks like there's someone there. And the last one, I think the best example I've seen of this, I mean, right now, under code, if the fire alarm goes off, they need to be a visual cue, strobing lights and things like that for people who may be hearing impaired, or if you've ever taken an airplane or ridden an airplane, they say that in the event of an emergency, knock on wood, these lights will turn on and guide you to the exits. You can have, by tying in network lighting systems with other fire systems or other emergency systems, you can have lighting scenarios that kick into play for letting people know there's an emergency, guiding them to exits, all sorts of things. So, really the sky's the limit when you think about, enhancing security with your advanced lighting systems. And you can see here in the example on the right, I mean, I've got one of these daylight motion sensors in the side of my house. The raccoons seem to set it off when they go after my garbage cans. But again, if that light goes off, I know there's something going on there. Usually it's just a raccoon. Sometimes, it's other things, not people, but, it's a cue to me that, hey, there's something happening in the side of my house. Maybe I'll take a look. Now, network, again, you're collecting information at a very local level, right? Sensors and things like that. If you're collecting information and you're able to link that with other systems, you can really overall enhance the building operations efficiency, et cetera, like that. So the most common is, probably through the building automation system or the BAS, is controlling HVAC systems. So your heating, ventilation, and air conditioning. Occupancy sensors say there's nobody there, the lights turn off. Signal goes through the BAS to say, hey, let's turn off or let's ramp down the HVAC system. Someone walks into the room, lights turn on, HVAC system ramps on as well. Same thing with maintenance management. We talked about, how you could kind of monitor systems and, anticipate when things need to be maintained, lights burned out and things like that. Security is great as well. We kind of talked about that, but I've heard of scenarios where occupancy is detected by a lighting occupancy sensor, the light turns on, and the cameras, which are on a bit of a swivel, will kind of go to where that occupancy sensor is. Again, the sky's the limit as to how you integrate these things. Building access, I always wanted to do this in some of my previous jobs. I never got to do it, but just say you're an eager worker and you're coming in, it's late at night or early in the morning, it's still dark. You tap your badge to get in, the door opens, but it could also potentially turn on the lights and light a nice path to your work area and turn the lights on there, maybe even turn on your computer. And then finally, event calendars. This is great for things like auditoriums where, they're not occupied 24/7. Occupancy sensors maybe are not the best solution for a number of reasons. Maybe occupancy sensors tied with other control systems. But, event calendars say, hey, we have an event coming this day, so let's turn on the lights, let's light up the atrium, whatever needs to happen. But again, you're moving information around, and the ability to coordinate with other systems is just really limited by obviously technology, but by your imagination as well. Okay, I'm not seeing anything in the chat, but let's get into a little bit about the system design, right? So there's several components that go into advanced lighting control systems. Obviously, we need hardware, right? So we'll talk a little bit about some of these things in the upcoming slides, but sensors are a huge part of it, be they occupancy sensors for saying, is there a body, is there a person in this space, to daylight sensors, which is, if you're lucky enough to have windows, sensing, how much light is coming from the outside, from the sun, and adjusting electric lights to make sure you get the right lighting levels, but minimize electricity use. There's timers to turn things on and off. There's controllers that, dim, change colors as well. Wall switches are a big part of it. Wiring, right? Or these could be wireless transmitters, especially if you're looking at network systems. That's something we need to consider. Gateways for moving information, and obviously the luminaires themselves, the things that actually house the lamps, which are going to provide light to the spaces. Software is a big part of it as well. This is really the brain. This is really, will kind of facilitate your ability to implement different types of strategies, right? You can configure, you could automate, set different scenarios. Maybe it's a push of a button at a central desk. Maybe it's, based on sensor information, change colors, change temperatures, etc. Can be preset. Some of these things are user programmable. What I've experienced though is sometimes the ability to do that, it really depends on if the software itself is open source or proprietary, right? Sometimes it's open source. You can go in on your own, or you have a energy manager focused on lighting, or maybe a building operator. They can make changes themselves. If it's proprietary, you may need additional training, additional tools. Maybe you need someone to come in from the outside to do that for you, which leads nicely to the next thing. I mean, there's, if we're going to do advanced lighting controls, there's obviously going to be some software components. Sometimes you purchase that software. Sometimes it's there through a software as a service agreement, which means the software will always be updated. You get people, the ability to call up people, usually dialing in remotely to adjust things and implement the different scenarios that you would like. User interfaces, right? So it's not just wall switches and things like that, even though those are obviously part of it. But you could see we've had a couple of pictures of people sitting in front of big screens, big dashboards, big controllers, mobile apps. This picture on the right here, I mean, you can pick up your telephone. You could do this for some of your lights at home, and through established networks, change the the lighting levels, the lighting colors, the temperatures, and all those sorts of things. But really, it is allowing people to have their own input when it comes to lighting control strategies. Now, we talked about advanced lighting control systems. They're automated, and that's a big part of it because people are not always the most reliable when it comes to turning lights off and things like that. But also, from what I've seen, you do need to allow some sort of human ability to control, right? People, they want the ability, they don't want the computer always, or the algorithm always dictating the light colors and temperatures, right? So just by allowing people some level of control, right? You can have overarching software limits and things like that, but allowing some, user interfaces will really go a long way to making people happier with the light quality and quantity in their area. When they don't have control, no one likes that, not having control. That's what people tend to have more complaints and things like that. Also, potentially more work for building operators or whoever's in charge, because if users can't maintain that, they're calling down saying, hey, I need the lighting level adjusted in my area, right? So again, some level of user interface or user control at the light delivery area is, in my experience, a really important part of these systems. Communication protocols, right? So we're talking about sharing data, right? So again, you can have open source or proprietary. BACnet, DALI are two common open source ones, right? Important because lighting technologies are made by different manufacturers. So, the brains inside their systems might be proprietary, but as long as they can speak to each other, then it really opens up the possibility of having different lighting control system components working together, and the opening up the possibility of having your lighting control system work with other systems, HVAC, security, et cetera, right? So again, something to keep in mind. I mean, I've seen it work both ways. Both work really well. But when it comes to sourcing these things, we would always ask, what is the communication protocol? And we tended to go more towards open source because, the way our buildings grew up, the way we implemented things, that meant we could really pick and choose different systems and different components from different people, know that they would be able to work together without being stuck with one sort of manufacturer and their own communication protocol. Okay, so let's talk a little bit different ways of doing lighting control system design. So first thing we're going to talk about is centralized system, where you could kind of see in the picture on the right, all of the things come into a single central controller, right? A single computer, something like that, right? So that's great. You have one place that controls all the lighting strategies and things like that. Really allows you to integrate. You could get information from one spot over here, feeds into a central controller, it impacts another one over there, right? So I talked about tapping your security badge to come in the building, right? That would work really well with a centralized controller, right? However, if you're tying information back to a single area, there's usually more information transfer that's needed, so maybe longer cable runs, and you potentially set yourself up for a single point of failure. If that controller fails, that one controller, you've lost all the ability to control your lights and your lighting systems until it's been repaired, right? Another one, which is sort of like centralized light or distributed, is where you do have some sort of centralized control, but it's more distributed. Think of it as different nodes, right? So it could be for a wing of a building, for a floor, etc. Right? That's great. It avoids the potential for a single point of failure. So if you lose one part of it, right, that's okay. All the other ones will be working as well. You just have one thing to fix. It could be potentially less expensive than centralized control because you're just tying things in locally as opposed to a central tie-in point, right? Potentially allows greater user customization. So if you have an area where, floor A and floor B have very different activities, they have more of that very important user ability, the user interface as well. But then you potentially have lost the single seat monitoring and control, right? So you've given off that to different areas, right? So it's much more work monitoring 10, 12, 30 different areas than one, right? Also, and this is something where, when I was doing lighting, this is something in which I was kind of leaning towards in many applications, was the luminaire level lighting controls, right? Or LCS, where you have sensors and your controllers embedded directly into each light fixture, right? Now, this is, allows really granular user customization, right? So you could set up controllers. We had systems where you could walk around with your phone and on a fixture by fixture basis using Bluetooth, set up the control strategy for that particular fixture, right? Great for retrofits and expanding systems. You want to do a retrofit, you don't have to worry about wiring and wireless communications. You plug these things in, you set them up, you calibrate them, and you're good to go. Also really good to expand systems. Do an area here, we want to do more, you could do it in a fixture by fixture basis. So potentially less expensive to install. The fixtures themselves, maybe cost marginally more from the fixtures that we were using, but usually the highest installation cost is the labor, etc. Right? So you save a little bit on that as well. Now, having said that, you definitely don't have that single seat ability to monitor and control system. It's on a fixture by fixture basis. So if a light burns out, you need someone to actually see it burn out or let you know that it's burned out as well. And very difficult to implement sophisticated control strategies. It's really on a fixture by fixture basis. So if you wanted to do something really sophisticated, you would have to go on a fixture by fixture basis, get out your phone or whatever, and set up the programming for that and have the foresight to know how you have to individually program all of these luminaires to get that scenario that you wanted. So not surprisingly, there are hybrid systems, right? Perhaps what you have is, distributed systems, and they're monitored through a central system. So the control is still at the local level, but they're monitored, or even at the luminaire level, and they're monitored, right? So you could see, it really depends on the functionality you're working for. Cost is a big part of it as well. I mean, I think the next slide we have here, yeah, it kind of goes over the centralized versus distributed versus LLCSs, the luminaire level lighting controls. I think these slides are going to be shared after. I'm not going to read all of this. It's too many words, but they all have different strengths and weaknesses, right? And it really depends on the ability to control, why you want to control, how much control you need will really dictate which system you put in place. So when I've done, I've been fortunate in my career, I've worked on, design of new buildings and things like that. And really what we had, depending on what was happening in different spaces, it was a combination of some centralized, some distributed, a lot of luminaire, and some hybrid as well, right? Really a costing system. Like cost was a big part of it. So for example, hallways, right? So hallways, it worked in healthcare for a long time. It really is lights on or off based on occupancy and maybe daylight, right? So that luminaire was great. But for meeting rooms, for auditoriums and things like that, we needed something a little bit more sophisticated. So we probably did distributed, maybe with centralized oversight, right? So again, the function taking place in the space really helped dictate which lighting control system design we incorporated. So very generally, centralized systems, may be better for new construction. Wiring is an issue. We'll go over some case studies, but in older buildings, wiring and communications is, it's not necessarily easy thing to do, depending on the types of ceilings, wire runs and stuff like that. So centralized systems are great for new construction, where from the get-go, you can say, this is what we want, and put your wiring, put your conduit in place from the beginning, right? Distributed systems, great for flexibility. So I really enjoyed doing these as a retrofit because we could expand, could modify, we could, we settled on one or two different types of fixtures, and those we could use to replicate lighting control strategies in different areas without having to have a centralized programming. We could say, hey, area A, we put these here, we're going to set up these fixtures slightly differently than area B, but still using the same fixture as well, right? And again, distributed systems, they really they give that real robust localized control, which is very, very, very important for user satisfaction, but also sometimes is required by the space as well. Okay, so let's get a little bit into some lighting control strategies. I'm not seeing any questions popping up here, but I know Prasanth is monitoring them. So the first thing, very common, are occupancy and vacancy sensing, right? So the simplest way to save energy with lighting is if the space is empty, if the lights are not needed, turn them off, or sometimes you need a minimum level of lighting for code requirements, dim those lights as well, right? So you can see occupancy, vacancy, similar concept, but slight but very important nuance between the two. Occupancy sensors turn lights on and off automatically in high traffic areas, right? You could see on and off, doing both. Space is occupied, lights turn on, unoccupied, lights is off. This is great for things like hallways, laundry rooms, where there's can be high traffic or they can be low traffic. Maybe it's time of day, maybe it's seasonal as well. Vacancy sensors, a slight nuance is that they often require a manual turn on, right? But they'll turn off automatically once no occupancy is sensed, right? So this could be for places where people, maybe can pop in quickly, right, to grab something, but they don't necessarily need the lights on, right? So instead of having those lights turn on and someone popping out, people come in, physically press a button on the wall, flick a switch, whatever it takes, lights turn on. As soon as that room has been emptied for a while, those lights will turn off automatically. You can see again, the function of the space will really determine which strategy you use. You got to understand, you need to understand what's happening in the space so you can design your lighting control strategy appropriately. When it comes to occupancy vacancy sensors, there are some differences. So there's the cliche, someone's sitting in their office and they're thinking really hard or whatever, or maybe they're in the bathroom and the lights turn off on them. We do not want that. That leads to complaints. That's going to lead to people disabling lighting control systems because we don't want to be having the lights turning off on us, right? So there's different ways of sensing occupancy. One is through active sensors. So they'll detect motion through ultrasonic sound waves, right? Sometimes they're audio sound waves as well. Passive sensors will use infrared to detect heat changes. So both of these have pros and cons. Active sensors, ultrasonic sound waves of detecting motion. But if you're sitting really still, or if you're sitting at a desk in an open concept area and there's a partition or there's a filing cabinet that's in between you and the sensor, that's not going to work as well. Passive sensors, will detect heat. So as long as you're not really, really cold, they'll detect heat changes to detect occupancy. But again, the line of sight for those has to be direct. So really easy to get something in the way of it too. So what you often get are dual mode sensors. The best in class to make sure that the lights are not turning off on people when they're in the spaces are dual mode. They'll have both ultrasound and passive sensors, right? It senses both of them, some ultrasound, ultrasonic detection and infrared. The lights will turn on. And as long as one of those things are detecting occupancy, those lights will remain on. As soon as they're both not detecting occupancy, those lights will turn off. So you can see some of these things, air currents, noises outside of a room sometimes can set these things off, right? So it's, again, the space itself and what's happening in the space, but also the adjoining areas as well will help dictate what sort of controller you use, what sort of sensor you use. Dual mode is very often what we settle upon for most areas because they had that both ways, the active and passive sensing, which is made sure that the lights weren't turning off on people. Daylight harvesting, right? So you could see in this diagram in the bottom, you got some daylight out here. The sun's coming up. The lights are on. As the sun gets brighter and brighter, the lights dim. It gets darker. And then, it's nighttime outside. And it looks like this woman has worked through the night, right? So the sun was rising, the sun set, it was night, and she's still here in the morning, right? So you could see that depending on how much daylight is sensed, it will determine how much electric light. So the daylight harvesters will measure the light levels, make sure that between the outdoor light, the daylight, and the electric light, you're meeting the light levels, but you're also not exceeding it. If you're exceeding the light levels, it's going to dim those electric lights. And notice what's happening here in the very right. You could see that this poor woman finally gets to go home. It's night again. And even though it's dark outside, there's some sort of occupancy sensor or timer or something like that where the lights are turning off, right? So if it was just daylight harvesting, those lights would probably be on, but also some sort of timer or occupancy sensor that's saying, hey, there's nobody here. Even though it's dark outside, we could turn off those lights. Time scheduling, this was very common for a while. I mean, I think sensor technology, the prices come down, especially installation is become much easier, especially with wireless these days. But it was not unusual to have lights on timers, right? Some of these timers, especially for outdoor lights, were astronomical timers so that, as the length of daylight changes, as the seasons change, it would adjust for that as well, right? Still useful in some instances. My experience, they're often been supplanted by daylight sensors and occupancy sensors. Again, maybe some applications where these still worked, but again, usually you'll see these maybe as a backup to occupancy or daylight sensing. Color tuning, right? So again, we have the ability not just to turn off the lights and save energy, but really impact the lighting environment, the lighting quality, right? So I love this picture here. I don't know where this is, but I mean, look at this. Like you can see in the left, it's like the sun is coming up and it's warm, and it's daylight and stuff like that. So I worked many years in healthcare, and the ability to impact light and have some natural lighting rhythms and things like that, huge, huge, especially for people who didn't have the ability to go outside, right? So you can support circadian rhythms, mood specific, special themes. I've seen restaurants where, during the day it's a bit more of a cafe, it's cooler, it's whiter, and then at nighttime when it gets more into restaurants, you see those lights not just dim, they change color as well to support the mood, to support the event. So a huge part of the lighting control strategies is, again, not just the quantity, but the quality as well. Task tuning and high-end trim, right? So you could capture lighting output. This is an interesting one. So, we did this in many areas where we had the ability to dim lights, right? And we capped it because the area was overlit. So we had these bulbs in, and we couldn't find a better lamp. So we would say the lights are on, we dim those lights. Well, it doesn't matter what type of lamp you have, fluorescent or LED, the light output is going to decrease over time. So we were also able to undim, if you will, right, as those lamps had reduced lighting output and extend their lifetime, right? So you could see it's just a really powerful way. I mean, obviously you need them on a single circuit here, but to control the light output for areas and by extension control your energy use. The most extreme of this is demand response, right? So if you're participating in this demand response, either intentionally because you're perhaps part of a program, or maybe there's been some grid issues and there's a call out. This happens from time to time when there's been some major events with the grid, right? You're able to reduce lighting and reduce your building's demand, right? Particularly related to lighting electricity, right? So this can be, dimming everything. This can be turning off, a few lights. Remember that you do need lights, they're the minimum requirements. But if you have this on the building basis, it adds up really quickly. Lighting could be, 10, sometimes even 20% of overall energy use, electricity use in the building. The ability to respond to different signals, price signals, whatever, can have a huge, huge impact on your building's energy use profile and costs. Personalized control zones. I mean, we have a few case studies. I didn't mention a project I worked on a number of years ago, but it was an open concept work area where there was lots of lights and everyone was complaining about the lighting levels, right? One person wanted it dark, another person wanted it brighter. There was no ability to turn lights on and off. So what ended up happening is they'd call down to the facilities group who'd come and take out bulbs or, maybe move a light and things like that. We implemented a system which allowed people to have control of the fixtures directly above their workspace, right? So that meant if, I wanted it really bright because I'm, reading something or working hard, my neighbor didn't want it as bright, I could have brighter light here, they could have, less light over there, right? And it was really, really powerful. Again, giving users that ability to control really went a long way to their satisfaction with the workspace. So you could see this can be done in a zonal area. Looks like in this space here that no one's working in the open concept space, so the lights have been dimmed, but the lights are on in the offices. Maybe it's a washroom or a photocopy room or something like that. Do people still make photocopies? I don't know, right? But you could see they've also got that beautiful wall in the back lit up. So lots of different things you can do in specific areas, which enhances the work environment. If you're turning the lights off, you're saving energy, but this is more about enhancing the work environment or the living environment or whatever environment you're lighting. I want to touch very quickly on power over Ethernet or PoE lighting, right? So this is a technology that uses the same cable to transmit electrical power and information to lights. So you could see you've got a power over Ethernet switch, and it's providing power to the lights, but also you've got some information. You've got a sensor here, looks like a wall switch and things like that. So it really eliminates the need for separate wiring. It can be a really, really interesting, powerful tool, just a different way of doing things. I mean, you're putting all of your lighting wiring in one wiring basket, so to speak, right? But you could see that, by having that information going through the cable, you can now do individual fixture control. You get rid of the need for high voltage wiring. It's easy to add components, reconfigure components. Each fixture, each sensor is its own addressable device. which means that if you're able to control it, you're probably able to pull data from these as well, and put that into some data analysis as well. Now, having said that, there are definitely things you need to take into account. Cybersecurity is a big one as we move more and more into automated systems and smart systems and web-enabled systems, making sure that people are not using these as backdoors for hacking in. Imagine hacking in to your building internet or intranet through the lighting system. Nobody wants that to happen. Cable distances are important as well. There are switches that have, maximum power loads, right? So yes, you can extend these, but there are some physical limitations. What I saw really was this bottom bullet point here was that the cooling requirements, right? So we looked at doing some of these as a retrofit for an area, and there just was enough space in the IT closet to add the extra equipment. But more importantly, these closets, I was in healthcare where more and more IT is being involved. They're already at their maximum for providing cooling to the IT equipment. That IT equipment was there for running computers, running diagnostic imaging equipment, things like that. I would have loved to do some of this, but there was not enough cooling. So had to back away from that. Looked at that at doing it for some new construction. So really interesting technology, but like everything else, it does have its time and place. So more, in my experience, better suited for new construction just because of some of these issues here. Sorry, potential issues. All right, so a few practical considerations. I think we're nearing the end. I see Prasanth has jumped on screen again, so I think I've got a couple more minutes. Right, so just in general, the more sophisticated the control systems, the more you're able to do with it in terms of quantity and quality. You can layer things, you can combine multiple strategies, right? Amazing. However, more sophisticated control systems means more stuff, more sensors, more wiring, more controllers, right? Which means more costs and more maintenance costs, right? So something to keep in mind as well, right? It's great when you put it in, but realizing that somebody, maybe your future self, 5, 10, 15 years from now is looking at maybe wholesale replacement of hardware, several software updates as well. And the other thing is control strategies are great, but when push comes to shove, we need lights for many different functions. So if our systems fail, be it the controllers, be it the communications, whatever, that these systems are set up to fail in an on situation. Prasanth, did you want to say something?
Yeah, so there's actually a question from the Q&A section.
Okay, I can't see it, so thank you.
Yeah, no worries. Thanks from Raymond. Is wireless lighting control a good idea, and how does it compare in terms of cost to hardwired control systems?
Yeah, so that's a great segue. Maybe we'll go into our case studies here. Right, so I'm going to jump ahead to the second case study, right? So Empire State Building, right? So an old building, and you could see they had a 3-year simple payback, huge energy savings on lighting and stuff like that. This was an old one, and you could see they went with a wireless system here, right? So they had daylight occupancy sensors, they had ballast, they could dim and things like that. And so I do a lot of energy teaching and energy management and stuff like that, and I get a lot of questions, and I give people warning that the answer to most questions is it depends, right? So really the big driver here is, wireless is great, but you have to make sure the system works. It's great because you don't actually have to wire things, so there might be some cost savings as well. But then wireless, you have to worry about powering the systems, being able to communicate. Depends if your control. When I was in healthcare, many times the control sensors were in the basement, so getting the information down there, right? So I'll say they both work really well. Wireless, in my experience, has worked great for retrofits where wiring can be more expensive, more disruptive. But having said that, wireless well planned out also works really well for new construction. So it really depends on your specific situation. What we would usually do is look at both. Sometimes, in healthcare, we had to worry about frequencies and stuff like that, especially in the early days of wireless. I think we're well beyond that, but the frequencies and potential for interference also comes into play as well. So I think both are good strategies, but my answer is it depends on your specific application. Empire State Building, old building, historical building. I could see why they went wireless. I wouldn't want to be the person who would have to go and rewire that building, right? So hopefully that answers the question. I skipped over one of the case studies here. You could see here, this is a Bluetooth one as well, right? They did a whole bunch of things, high-end trim, huge energy savings. This is very similar to, something I did. I did something like this back in, I hate to say it, 20 years ago, right? Open concept where we put in new dimming ballasts. We put in individually adjustable fixtures. There were no wall switches. We tied in wall switches, centralized control, and things like that. Again, I did this over 20 years ago, and there's still like a 2 or 3 year payback on this, right? So a lot of work, but you could see that, especially something like this, where you have lots of people, maybe there are wall switches, maybe they aren't, but who's turning off that wall switch, right? So the ability to tie this either as part of a distributed centered or centralized system, tie in some occupancy sensors, right? You need more than one, right? Because if the person in the back of the office is still working, but this place is empty, you don't want the lights to turn off on the person who's still there. So there's some thought that that's required, but it works really well for open concept areas or shared spaces and things like that. And then very quickly, I realize we're getting close to time. So this is a great one. There's a link here. I think the slides are going to be shared. So this is good because it showed it was a meta study of over 200 or almost 200 lighting control projects, and the paybacks are great, 2 to 5 year payback. There are often incentives. I do believe the IESO offers incentives. 50% savings on average for electricity, right? So you could see. This is great. I mean, this is the dollars and cents of it. But when I did my projects, I always made sure I enhanced the light quality aspects as well. The ability to change colors, all those sorts of things are so important, right? So this is the driver. This is going to give you the financial business case to go ahead. It was all those other things, which I'd love to talk about. Maybe it's time for a different webinar, which really help push these things ahead. And with that, I'll hand it over back to you, Prasanth. I mean, we'll do some questions, or do you want to do the last few slides?
There's actually one question here from Raymond again. What is the typical life cycle for a lighting control system?
Yeah, so it depends how sophisticated it is, right? So I'll say it depends. It's the life cycle of technology, right? So there's three things that can happen. Your hardware can go obsolete, right? Your software can go obsolete, or things can fail, right? So technology is pretty hardy, so these things can easily last 3, 4, 5 years and beyond, right? I've seen older lighting control systems that were 10, 15, 20 years old. The problem with those is that their functionality decreases over time. They couldn't accommodate new software updates. They didn't have the same functionality and things like that. So again, it depends, but I'll say, what, with good technology, you should be able to easily get, let's say 7 years out of your technology, if not more, right? Which is one reason I really like the luminaire level lighting controls, is because you're doing it on a luminaire basis, right? So you're just replacing as needed. You don't need to do these wholesale replacements as well. Another factor for consideration when you're choosing what the type of system you want in place.
Perfect. Thank you, Ed. Is there any other questions from anyone else? We still have 7 more minutes till the end of our session. Okay. In the meantime, we can just go over the next few slides, and then if you do have any other questions, feel free to raise your hand and ask, or you can message in the chat as well. But on this slide, you can just see, as you're aware of our capability building program. So just visit the training support link here, and you can get access to the other amazing sessions that we have planned. To answer the question before, yes, this deck and recording will be made available later this week. Oh, I think we have a Q&A. Yes, we have another Q&A question. You showed a slide how light was controlled via a daylight sensor, and the light was turned off at night via a motion sensor. What type of dual controller would that be?
So I was guessing it was an occupancy sensor, right? So the daylight sensor will measure the outdoor light, and then it could be an occupancy. I'll say a dual mode is probably the best in class, especially for like an open concept or that office setting that graphic was describing. It could have also have been a timer as well, right? So or it could have been all three, right? But my experience is something like that will be a daylight sensor combined with some sort of occupancy and or vacancy sensor, dual mode, right? They could be two separate sensors coming into a controller, which is the algorithm, which will say, if there's no occupancy and it's dark outside, the lights can be off, right? If there's occupancy and it's dark outside, we need to measure the light level and adjust the electric lights to get those preset lighting levels that we're aiming for.
Perfect. Thank you again, Ed. We can go to the next slide for now.
Yep.
Yep. So this is just some incentives for some training courses offered by Save On Energy, up to 50%, and listed below here. On the next slide, we have incentives for Enbridge customers as well. So incentives up to 75% for the following 3 courses. Again, these slides will be provided to you, so you can just go through them after. And the next slide, we have some tools. So training support webpage. Again, we can find other sessions for other webinars. We have a live training calendar. You can see all of the events coming up for the next 4 to 8 weeks, typically, and if not more. We have a monthly bulletin. So if you sign up for the monthly bulletin, you get live training updates through your emails and any upcoming sessions as well. And then you also have the one-on-one coaching post-webinar intake form. You fill out the form, and then we can get maybe a one-on-one expert for you to have a one-on-one coaching. The next slide we have, so this the one-on-one intake form again. And then right now, if you could, you'll get an email shortly after this session. It will take you just 2 to 3 minutes. Quick survey on your feedback on the session, on how we did, on how Ed was, and on the topic. And this helps us a lot for creating future sessions and managing content in the future. So a few minutes, if you can provide your feedback, that'd be great. So you can see all of the social media handles here for Save On Energy, Facebook, LinkedIn, and Twitter, and as well as the official website there on the top. Feel free to reach out there as well. And we still have 3 more minutes for any other questions. So we'll be here waiting for your questions, and
ask away.
Be nice. Yeah, ask away. You can raise your hand and ask too. But if not, thank you everyone for attending.
Thank you, everyone.